Today, we are going to look at two upscalers, one for Z image and one for WAN. Both are quick and both are good. Z image first. You need to be on the latest comfy version, and if you pop to the comfy org hugging face page, links below, you can find the models. Standard affair of a simple Z image workflow at the top. At the bottom, we have the PID section. For those of you who follow me, you can download this and the next workflow off my Ko-fi page. For those that do not follow me, then you shall have to squint and see how I set it all up. The PID section needs the prompt off your generation. I just used a text box to feed both clip encoders. We are using the 1024 to 4096 upscaler. The settings are all set. PID only does square images. You will suffer artifacts if you change the aspect. If you look at this pre-rendered woman, we can see the effect of the upscaler. The upscaler does add a little bit of noise to the process. This means it potentially can change things. Fortunately, the noise is low and does not wreck images. Let's give this fucker a workout and make some images. As you can see, the Z image has made the first part. We have a new woman in the top section. That image now runs through the second section. As I zoom into the comparer, I am getting around 1 second for a Z image to be generated. Then we load the models and do the second stage in around 40 or so seconds. Most of the time is model swapping. Now we shall do some more challenging pictures. So enough of the pretty women and time for some Geiger art. I will warn you that I may have to cut some images out of this video as Geiger. Well, he can be very not YouTube friendly. We shall see. Nope, I cannot zoom into that one. Ha 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 ha. I did warn you. Right, let us look at this skull type effort the Geiger Laura made. You can see it adding some detail to the cracks in the skull, and then on the serpent head. It is not wrecking the image. For a rather quick upscale, the results are quite nice. On to the Wan upscaler. This works slightly differently. This upscales from the VAE. This is massively faster. I was getting generations and upscale in 19 seconds flat. We use a special VAE node and a special VAE model. These do the upscaling for us, so no second pass needed. Links for the nodes are below. As I make the random blonde woman using a LoRa, you can see we get a nice 3000 x 3000 resolution image. However, the Wan VAE upscaler does not have a hard size limit that the Z image did. So I am going to chain two Wan VAE nodes by encoding and then decoding again. So we are upscaling twice in the same generation. We are now going to go over 6000 times 6000 for image resolution. I was getting this done in 39 seconds on a 5090. Your VRAM will be the limit as to how many times you can chain VAE encode and then decode blocks. In theory, you can get up to 12K images if you have the hardware. VAE simply explained when they encode. They shrink images down to tiny sizes, and when they decode, they blow them back up again. So asking a VAE to make the image twice as big as it should is sort of natural to what they are designed to do. I will leave the science there. There is no noise in the VAE, so it is not diffusing, which is why it is quick. This means this is a gentle upscale. This will not detail fixed crop photos, for example. The process will, however, pull some detail out as we look at other examples. As we look at some more Geiger artwork, we can see that whilst the VAE is gentle, we are getting some enhancement and, well, a very scary looking large image. I have noticed that other YouTubers have been saying that the PID upscaler only works with Flux or Z image, etc. This is a load of bollocks. I have got PID to work on any, and I mean any image model, and the same for the WAN one. I am currently making a custom node to hook up to any workflow that allows you to choose either method shown today. Keep an eye on my Boya nodes pack for it. If you like this stuff, support me on Coffee. Also, come to my Discord to say hi. All links are below.